Hi, in this video, we're going to be going over Chapter 10 TI Nspire skills. This both includes confidence intervals for two sample z intervals for proportions, two sample t intervals for means, two sample z test for proportions, and two sample t test for means. In both of the t intervals, we're going to go through both using stats and data because those are two separate calculator skill sets. So our first example is going to be a two-sample z-interval for the difference of proportions. In this example, we had sample proportion of 50% who approved Obama's job performance in a sample size of 1,024. In 2009, we had 53% who approved Obama's job performance in a sample size of 1010. So you can't just type this directly into the calculator. You have to type in the original fraction of the sample. For example, for P1, you can't type in 50%. You have to type in 50% of 1024. And what is that? That comes out to 512 out of 1024. Same thing, 53% of 1010 comes out to approximately 535 out of 1010. And then we're going to use these two sample statistics to construct a 90% confidence interval for the change in Obama's approval rating among all US adults. Let's hop on to our calculator. So here we are at the home screen. We're going to hit the home button. We're going to go to our calculator app. We're going to hit menu. We're going to go down to statistics, confidence intervals. We're constructing what we call a two-sample z interval for proportions. So we're going to look for the number 2. There's two sample z, but this is the one we want. 2 prop z interval for two-sample z interval for proportions. The first part right here says successes x1 over n1. So if we go back to our original fraction, we had 512 out of 1024, and we also had 535 out of 1010. Those are the two values we're going to put in. 512 out of 1024, 535 out of 1010. We want to construct a 90% confidence interval, so we're going to change this to 0.9, and we're going to hit OK. Let's copy some of this information right over. So if you look, it actually has all of our answers right here. C lower, C upper. We even have our margin of error right there. But I want to make sure you guys also know how to work through the math for showing your work. Here's the formula for the two-sample z-interval for proportions. It's P2 minus P1 plus or minus the critical value z star times the square root of P2, 1 minus P2 over N2 plus P1, 1 minus P1 over N1. We already know P2 and P1, so let's fill in those values. You notice we didn't fill in the critical value. The unfortunate thing about this calculator is it doesn't feed the critical value, but we could quickly review how to do that. Remember, for a 90% confidence interval, we want the middle to contain the 90% of the data, but the calculator can only spit out left to right for the inverse norm function. So we're going to actually have to type in 95% using the inverse normal function. So how do we do the inverse normal function? You go to Menu, we're going to go to Statistics, 6, Distributions, 5, and unlike Menu 652, this one's going to be Menu 653. We're going to type in an area of 0.95, and we're going to hit OK, and we get our critical value of 1.64485. So now that we filled out this value, the calculator actually did all the work for us. We don't actually need to crunch these numbers in. Our difference, 0.53 minus 0.5, the true difference is right there, which is negative 0.03. Hey, that's a little bit strange. We wrote it this way. Just flip the signs because they actually did P1 minus P2. So this is going to be 0.03 plus or minus. Our margin of error is 0.03643. That's all of this put together. Notice that our lower bound and our upper bound goes into the negatives. But if you look at the expression we wrote, that should go into the positives. Again, the calculator flipped it. So let's just flip the signs. C lower will actually be our C upper. When we flip the sign, it's going to be going up to 0.066. And then the lower will be negative 0.0067. And there we go. That's how we construct a two-sample z-interval for proportions. In our next example, we're going to take a look at confidence intervals for two-sample t-intervals for means. Here we want to construct and interpret a 99% confidence interval for the difference in mean capacity for target and Bashas. So we're going to have to type in this data, and let's do that very quickly. Remember, we want to start a new document. You go to Home, you go to New Document, and then we could go to our Listen spreadsheet to enter in data. We're going to type in target for the first column, and then Bashas for the second. And make sure you guys enter in the data. Once you have your data in, again, we want to construct a 2-sample t-interval for sample means. We're going to go to Menu from here, go to Statistics. We want to go to Confidence Intervals, and we're making what we call a 2-sample t-interval for sample means. Remember, for means, we never use z, we always use t. The data input method was the data we used. List 1 would be target. List 2 would be Bashas. If you guys remember the question, we want to construct a 99% confidence interval. And we have all of our data right here. A faster way to view all of this data at once is to actually go to the Calculator app, hit Home, go to the Calculator app. You're going to go to var. And then we're going to type in stat.results. So if you scroll down, stat.results will just push out everything we just saw on the screen. But it's just a little bit easier to see. And we could copy and paste this over. At some point in this problem, you probably had to check the graph to check for normality, no outliers. So how would you do that? You can construct a graph by hitting Home, going over to the bar graph. We could click to add variable, and we could put in target. At this point, you're going to right-click right here. So right-click, you hit Control, Menu, and then when you do that, you could add an X variable, and we're going to add Bashas. So now we have target and Bashas. And the best way to look for no outliers is to look at the box plot. So you just go to Menu, Plot Type, and go to Box Plot. Now we can see that there's no outliers. There's also only 5 points, so this is not maybe the best example to use. Let's also copy this over. So let's quickly review how to go over the 2-sample t-interval for sample means. I want to keep this consistent with the calculator this time. So instead of going x2 minus x1, we'll do x1 minus x2, plus or minus the critical value t star times the square root of our standard deviation over first sample squared over the sample size of the first sample, plus the standard deviation of the second sample squared over the sample size of the second sample. We have all the values. For example, x1, the sample mean of first sample mean of the second sample. Let's fill those in. Critical value, again, this is where we need to pull it out of the calculator again. We have a 99% confidence interval. That means we want to use an inverse t of 99.5%. So let's go to our calculator very quickly to pump that out. We want to go to our calculator app. So if we go to our calculator app here, we could hit Menu, 6, Distributions, 5, and instead of Menu 653, inverse normal, this time we're going to do Menu 65t. Our area was 0.995. Oh wait, what's our degree of freedom? Now if you use the conservative degree of freedom, you should be using n minus 1. Here's the problem. There's actually a more complex calculation for the degree of freedom. The degree of freedom pumped out by the calculator was this, 7.513. So we're going to be consistent and use that value as well. 7.513, and we're going to hit OK. This time we get a critical value of 3.4195. Let's copy that down. Now that we have our critical value, we can finish off the equation. We have our standard deviation 1, standard deviation 2, and our sample size for both of them was 5. So let's fill that in. Remember, the likelihood of you making a mistake and typing this is actually quite high. Just a calculator error, you'd miss a single digit. So remember, our calculator did everything for us. For example, the difference in means was right here, 3591.8. Plus or minus, all of this right here was our margin of error, which is right there, 3692.746. It automatically calculated our lower bound for our confidence interval and our upper bound, which we can just put in right here now, negative 100.94 and 7284.54. In some cases, the problem won't give you the data, it'll just give you the stats. In that case, it'll just give you this with the sample size N1 and N2. And you could also do that directly into the calculator. Let's remember these values right here, and I'll show you how to do this on the calculator as well. So what we're going to do is we're going to construct a two-sample t-interval. We're going to hit Menu, Statistics, Confidence Interval. We're constructing a two-sample t-interval for sample means. We're going to hit Enter. We're going to go to Stats, hit OK, and we're going to have to type in all those stats in. We typed in all the stats right here. Let's scroll down a little bit. We used a 99% confidence interval, and we just hit OK. And again, it should produce the exact same values we got previously. In this next example, we're going to be doing a two-sample z-test for proportions. We're going to be comparing two samples and comparing the two proportions. In this example, we had women versus men. In a random survey of 500 women, 315 said they would rather be poor and thin rather than rich and fat. This comes out to about approximately 0.63. And then for men, we only sampled 400 men, but then we had 220 who said that they would rather be poor and thin rather than rich and fat. This value comes out to approximately 55%. Again, this could have occurred by chance variation based on our random sampling. So we want to see if this could have occurred by chance. We're going to assume that the proportions could have been equal. That's going to be our null hypothesis. An alternative way of writing this is P1 minus P2 is equal to 0. Our alternative, again, is what we're testing for is that the women's proportion is higher than men. And we could already see that in the sample data right there. Alternatively, we could have written this P1 minus P2 is greater than 0. For the calculator, all you're really going to need are these two proportions right here. So on the calculator, we're going to go to the calculator app, Home button, Calculator app. We're going to hit Menu. We're going to go to Statistics. We're going to go to Stats Tests, because this is a hypothesis test. This is a two-sample z-test for proportions. So we're going to look for two-sample z-test. This one's incorrect. We're going to go to two-prop z-test. That's actually the two-sample z-test for proportions. All we're going to need are the two fractions. For women, it was 315 out of 500. For men, it was 220 out of 400. If you remember our alternative hypothesis, we were testing to see if P1 is greater than P2. So if you mouse over this, and then you could select one of these three options, P1 greater than, not equal to, or less than. We're going to choose the top one right here, and we can hit OK. And then we have all of our data right here, and we could copy and paste this over. So when you do this, you'll notice that we have both of our answers. We both have the z-score and the p-value. We even have the proportions calculated for us right there. So you didn't even need to do this calculation by hand. But there's another thing that we're going to notice right here. It's p hat right there. And there's the p combined, which I talk about in the formula. So we're going to have to know how to plug this into the formula. Let's write it out. The formula is z is equal to p1 hat minus p2 hat all over the square root of p combined 1 minus p combined all over n1 plus p combined 1 minus p combined all over n2. And then we're just going to be able to fill in these values. So z is equal to p1 was 0.63 minus 0.55 all over the square root of the p combined is right there, 0.5944. If you recall, we already know our sample sizes. It was 500 and 400. And again, you don't need to type this into your calculator because you already have your z-score and your p-value. So we know that this entire expression turns into 2.42886. You don't need to hit menu 652. It already did it for you. The p-value for this, the probability that z is greater than or equal to 2.42886 is going to be equal to 0.00757. You're welcome to use the menu 652 command, but this one we could get away without using it. In our last example, we're going to do a two-sample t-test for means using stats or data. Now we're going to start off with data, as you can see right here, and then we're going to move on to stats because it's easy to move from data to stats. So you know that you're gonna have to put all this information in. If you didn't read the problem, I'm pretty sure you could just quickly label this as the calcium group and the placebo group, or group 1, group 2. So we have all this crap on our calculator. We want to clear it. So we're going to hit the home button and we're going to create a new document. We don't want to save all this. We want to add list and spreadsheet. And then we're going to title one of them calcium and the other one placebo. And then we're just going to fill in our data. Notice that they were 2 different sample sizes, and it's reflected in our spreadsheet as well. So in this problem, we want to see if the calcium supplement reduced blood pressure more than a placebo. And here's our calcium group right here. Let's call this group 1, and the other one's group 2. We want to see if the mean reduction in blood pressure for group 1 is greater than the placebo group. So our alternative would be is mu1 is greater than mu2. And then our null hypothesis would always assume that they're equal to each other. We could write the alternative way of writing this. Mu1 minus mu2 is equal to 0, and mu1 minus mu2 is greater than 0. So in our calculator, we're going to want to hit the menu button. We're going to go to Statistics. We're going to go to Stat Tests, because this is a 2-sample t-test for sample means. So notice that we're looking for 2-sample test. There's 2 of these. We never use 2-sample z. We always do 2-sample t for means. This time we're using data, so all we have to do is just crunch in the data. Our first list was our calcium group, and then our second list was our placebo group. Then we're going to go to our alternative hypothesis. Again, we have our 3 options. Our alternative was mu1 is greater than mu2. And then you could go down and make sure you could hit OK. And again, you could scroll through here and you can see all the different things you need. I'm going to show you guys how to observe all of it in one page. If you hit the home button and then you go to the calculator screen right here, you could hit var and then go to stat.results and you hit enter, and it'll print everything so you can see it in one tight little spot. And we'll copy and paste this. So you're going to want to remember how to write this out as a formula. And then what's nice about the calculator, it pumps out all the statistics you need. So here's the formula. It's t is equal to x1 minus x2, sample mean 1 minus sample mean 2, all over the square root of standard deviation of the first sample over the first sample size plus the standard deviation of the second sample square over the second sample size. Let's fill in the values. T is equal to, our sample mean 1 was 5. Our second sample mean was negative 0.2727, all over the square root of, our standard deviation for the first sample was 8.74. We're going to square that over our first sample size of 10, plus our second standard deviation, 5.9. We'll square that and put that over our second sample, 11. And that's going to be crunched out to be equal to, well, t is equal to 1.603717. So you don't need to type that again. You just want to use the calculator's value because it does it all for you. We don't actually need this degree of freedom in any of our calculations because it already crunched out the p-value for us. So you could just kind of ignore that for this one. For the confidence interval, you do need it. So the probability that t is greater than or equal to 1.603717 is going to be equal to 0.064419. And there's our p-value, and that's how you use it on the calculator. Let's take a quick moment to do this using the stats feature on the calculator as well. You're going to want to remember all of these values right here because typically I'm going to have to feed those values to you, or you're going to have to be getting those values from somewhere at some point. So coming back to our calculator app, the way you would do this is you would just use the calculator app right here. You hit the menu button. We're going to go down to Statistics. We're going to go to Stat Test. We're going to go to 2-sample t-test again. If we don't have data and we're given stats, you choose the Stats button right there. And then you're going to have to enter all this information in. You want to make sure that your alternative hypothesis matches the previous one, that mu1 is greater than mu2. And then we could hit OK. And then you can compare and make sure that these values are very similar to the previous ones. All right, guys, that's it for the Chapter 10 TI Nspire skills. I hope you found this helpful, and I'll see you guys next time.